So good morning students, welcome back. Today we will discuss numerical based on resistance and on Kirchhoff law. Look at students, what we are given. We are given a cube having 12 sides and each side having resistance as small r. So 12 sides having resistance small r, each side having resistance small r. Okay, and this circuit is connected with a cell, okay, having potential V and with a switch. Okay, now he is asking find equivalent resistance of this circuit. We are given a cube, each side having a resistance small r, cube having 12 sides, so each side having resistance small r, and this circuit is connected with a cell having potential V and with a switch, and he is asking find equivalent resistance. How can you find the equivalent resistance of this circuit? Before finding resistance, I'm going to explain the direction of current. Look at students, when switch K is on, in that condition, current I will flow through cell, and at the point B, at this point B, at point B, current I will divide in three parts, three equal parts, I upon 3, I upon 3, I upon 3. I divide in three parts because all three sides having equal resistance, so current will equally divide. I upon 3, I upon 3 and I upon 3. Okay, look, this I upon 3, when come at the point C, it further divided in two parts. So half of I by 3 is I by 6, I by 6. Okay, similarly, this I by 3 further divided in two parts, I upon 6, I upon 6. Similarly, this I upon 3, when come at this point, it further divided two parts, I upon 6 and I upon 6. Now the next important portion is this I upon 6 and this I upon 6. When we'll add at this point, it again become I upon 3. This I upon 6, that I upon 6. When add at this point, again it become I upon 3. And finally, when this I upon 6 and that I upon 6 will add at this point, it again become I upon 3. And finally, I upon 3, I upon 3 and I upon 3 will add at this point and it become I. So total current remains I. Understood? In this way, we can complete the current of circuit. I'm going to apply Kirchhoff second law. That is also said to be loop law, voltage law. Why it is said to be loop law? Because it is applicable for closed circuits. That's why it is said to be loop law, or sometimes it is said to be voltage law. Look students, I am going to apply Kirchhoff law. In which loop? See the loop A, B, C, D, E, F, G and A. In this closed loop, look at students, see the path. In this path, I am going to apply Kirchhoff's second law. And how can we apply Kirchhoff's second law? This is a rough portion of a second law. Sigma E equals to sigma IR. On account of this, we will find the equation on behalf of Kirchhoff's second law. Look students, we will start from positive terminals and will come at negative terminals. Okay, and in this path, we will multiply current with its resistance. Look at students, we will start from this point, plus terminals. Okay, look at, when we start from this point, first of all, the resistance comes of this wire, that is R, and its current I by 3. So current multiply with its resistance, I upon 3 multiply with R, I upon 3 into R. Okay, when we come at this wire, its resistance R and current I by 6. So I by 6 multiply with R, I by 6 into R. And when we come in this wire, in this path, its resistance R and current I by 3. So R into I by 3, current into resistance. And then after, there will be no resistance. We'll complete our path, positive terminals to negative. And what we did, we just multiply current into its resistance. Okay, now students, sigma E equals to sigma IR. On account of that, current into resistance will equals to voltage of the cell. We are given V as the voltage of cell. So we'll write V in equivalent. Okay, students. So this is basically Kirchhoff law. Sigma E equals to sigma IR. Okay. Now students, on adding all these, we'll get 5/6 IR. Okay. By this path, we got the equation 5/6R. If we follow this second path, either if we follow this third path, we'll get the same equation. So what to do for getting second equation? This time I'm applying Ohm's law for getting terminal voltage. What is Ohm's law? V equals to IR. Now compare first and second. When left hand side equal, right hand will also equal. So IR will equals to 5/6 IR. Okay students, I to I cancel out and we'll get capital R equals to 5/6 small r. It means capital R is total resistance, and it is said to be equivalent resistance of this circuit 5/6R. Okay, this type of question generally comes in JEE examination and in board examination. Hope so you will not face any difficulty in understanding this question.